Hello, hope to answer the following questions. You said worksheet 2, problems 2, 3, 8, 10, 12, and 13. Let's start off with questions 2 and 3. First of all, this worksheet talks about geometric series or sequence and series. So let's make sure we understand what geometric sequences are. For example, problem number 2 gives me the following set of numbers. The number 100, 30, 9, 2.7, comma, dot, 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 meaning this pattern will continue. So we've been dealing with looking for patterns in the series of numbers that we've been given over this entire week. A geometric series is dealing with multiplication. And so if my numbers increase or decrease by a multiplied number, that makes it a geometric series. And so I'm not adding or subtracting a specific same number to get from each of these numbers. I am either going to be multiplying or dividing by the same number to get the next term. And so in this particular problem, I know that this is a geometric series because if I take the second term, the number 30, doing this on my phone, so bear with me, the number 30 divided by 100, I get 3 over 10 or a decimal of 0.3. If I do that to the next two terms, meaning 9 and 30, so if I take the number 9 and divide it by the previous term, I get 0.3. And I can check one more just to be safe. If I take 2.7 over here, 2.7, and divide it by 9, I also get 0.3. So if you notice, if I take each number and times it by 0.3, I'll get the next number. Times this by 0.3, I get the next number, and so on. That 0.3 is known as my common ratio, which I'm going to need here. Common ratio, the multiplier or the divider that makes me find the next number in my series. So since all of these are the same here, I know that this is a geometric series, okay? And so for this particular problem, you're being asked to write a recursive formula, an explicit formula, and then find the 10th term. And so to find a recursive formula for a geometric series, we need to know the following parts. A recursive formula, write this out here, has two parts to it. We always write the first term, which is a sub 1 equals, and we write the first, F-I-R-S-T, term of my series there. And then we write the part which is considered the recursive formula piece, and it's always going to be in this format. A sub n minus 1, this means the previous term. And then I'm going to times it by r, which is my common ratio up here. And r, I'll write that here, is common ratio. Now, recursive formulas always have a third piece, but I generally don't ask for it all the time. But we want n, whatever value you put in for n, must be greater than 1. So these two pieces are needed for a recursive formula. So if I'm going to write a recursive formula for this problem here, I write, so here's the answer to problem number 2. So I write a sub 1, and I write whatever the first term is of my series. So the first term of this series was 100. So I put 100 here. Now I write the second line right here for my recursive formula, and it's always this. Again, a sub n equals a sub n minus 1. Now in this piece here, I know what my common ratio is, so I'm going to times it by 0.3. Okay, so I've just answered the first part of this problem, and that's writing a recursive formula. Now in explicit, it asked me to write an explicit formula. And an explicit formula for a geometric series is always in this format. It never changes. A sub n equals, and again, a 1, which now we know is the first term up here. Up here, as you can remember seeing that. But I write a sub 1 times the common ratio raised to the n minus 1 power. And again, there's a second piece to this, n is greater than or equal to 1, but I'm generally not necessarily looking for that when I go to look for an answer. So if I'm going to write an answer for this problem here, an explicit formula, again, I write a sub n equals, well, a sub 1 is my first term, and I know my first term up here is 100. So I write 100, and I'm going to times it by my common ratio. So I'm going to times it by 0.3, and I'm going to raise it to the n minus 1 power. Okay, so there's my final answer to problem number 2. Here is my recursive formula. Here is my explicit formula. Now, when you're being asked to find, like in this case, it wants you to find the 10th term of the sequence. Well, the explicit formula is always the best thing to use. In order for me to use the recursive formula, I need to know the term before it. So if you notice, I have term 1, term 2, term 3, term 4 here. Well, if I want to find the 10th term, I need to find the 5th term, the 6th term, the 7th term, the 8th term, the 9th term, and finally the 10th term if I use the recursive formula. The explicit formula allows me to skip straight to the 10th term. And so the way I do that is I come down here and I use the explicit formula. So I want to find a sub 10. So 10 is the term that I want to find. So I just plug in 10 where I see an n. So I go 100 times 0.3, raise it to the 10 minus 1 power. And if I plug that into my calculator, I find out that my 10th term should be, I think it's kind of a small number, 0.0019683. So using the explicit formula, it allows me to skip having to find all the terms before the 10th term. I can just go straight to the 10th term and find that. So that should help you do the rest of number 1, 3, and 4, even though you didn't ask for those. But for number 3, you should notice it's not geometric, because if I take the second term and divide it by the first term, I get an answer. I get 0. Then if I take the second term or the third term and divide it by the second term, I don't get the same thing. In fact, it's undefined. And then if I take the last term, 10 divided by 5, it's not the same as the previous ones that I had checked. So that should help you out a little bit there. Now, if I go to problem number 8, I need to identify whether it's arithmetic, geometric, or neither. And so problem number 8, okay, it's a good problem because we've been working with the arithmetic and geometric series so far, and you should be able to tell which one's which. So I go 9, 3, 1, 1/3, dot, dot, dot. Now, let me get out of there so we know that it's different. Now here, again, to always find out if it's arithmetic or geometric, take the first term and, if you notice the difference between these two. So if the difference between these is to go from a 9 to a 3 is -6. Now, 3 to a 1 is a -2. If you notice, these two things are not the same. If they were the same, if it was -6, -6, -6, -6 to find the next terms, then it would be arithmetic. So automatically, since these are not the same, I know it's not arithmetic. So now I go 3 divided by 9. So I take the second term and divide it by the first term. And if you notice, I get 1/3. Now if I take the next term, 1 divided by 3, I also get 1/3. If I take 1/3 divided by 1, I get 1/3. So all of these are the same. So it's a common ratio. So that tells me it's geometric, with a common ratio of 1/3, meaning to find the next number in these series, I keep multiplying it by 1/3, and that'll give me the next number. And so to find the next two terms, I take 1/3 and I times it by 1/3. So 1/3. I'm going to times it by 1/3. I get 1/9. So that's the next term. And then I take 1/9 and I times it by 1/3. And I get 1/27. And that's my next two terms in this series. So hopefully that helps you out there a little bit with number 8. And then you should be able to find number 10. If you notice for number 10, you can add or subtract a number to find the next new number. So let me know if you have any questions about number 10, but I want you to give that a try now that I've talked about that a little bit. Number 12 and 13. So for number 12 and 13, you're being asked to add a series of numbers that are, you need to determine if they're an infinite series or a finite series. And as you can tell for that problem, they're infinite. So let me write this down for number 12. So for number 12, the number is 40 plus 20 plus 10 plus blank, 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 meaning you're still adding. And then they want you to find all the 10 terms. So when there are 10 terms, so right now I only have 3. So what would the other 7 be? So you can, 3. So what would the other 7 be? You can either find them or you can use this shortcut. So when n equals 10. Now, for first I need to determine, are these numbers, is it a common difference or a common ratio? And in case you're wondering, let me try to find the notes on this so that I can tell you what page to specifically go to. But if you go to page 595, it's for geometric series, and you would use the equation at the bottom of that, which is this. It says this: S sub n, n is the number of terms that you know you're trying to find, and it says you take the first term, a sub 1, and you're going to times it by 1 minus the common ratio raised to the n power, all divided by 1 minus the common ratio. Now, this is for a geometric series. If you're adding up a bunch of numbers that increase or decrease by a multiplying number, then you use this one, okay? And so now, if you notice, I would have to subtract 20 to go from 40 to 20. And then if I subtract 20 from 20, I would get 0, but I get 10. So it's not going down by the same amount. So this is going down by 20, this is going down by 10. So I automatically know that this is not arithmetic, it's geometric. In fact, if I come over here and I take the second term, 20, and I divide it by the first term, 40, so 20 divided by 40, I get 1/2. If I take the next term, which is 10, so I come over here and I do 10 divided by the previous term, which is 20, I also get 1/2. So 10 divided by 20 is 1/2. So if you notice, each number is getting multiplied by 1/2 to find the next number. And so this is my common ratio. So now I can actually solve this problem. So I want to find s to the 10. So n is 10. My first term is 40. 1 minus, we found what r was, my common ratio, which was 1/2. So I put 1/2 here. And it's being raised to the n power, which is 10 again. All over 1 minus my common ratio, which is also 1/2. Now, be very careful when you try to solve this using your calculator and do PEMDAS. So remember that you're going to have to raise the 1/2 to the 10th power first before subtracting it from the number 1. So if you plug all this in and you do it properly in your calculator, you should get 79.9. And it's a shortcut of doing this. Otherwise, you'll have to find all the 7 missing terms and then add them all up. This helps you so you don't have to. So keep that in mind. For number 13, again, if you look for number 13, here are the numbers. 4 plus 12 plus 36 plus blank, we don't know. And in this case, you need to find 15 terms. Well, that's going to take forever. You have to find the next one. Well, make sure to look. If you notice, to go from a 4 to a 12, I have to add 8. Well, if I add 8 to 12, that would make 20, but it's not the next number. So it's not arithmetic, it's geometric. In fact, I noticed that if I take 12 divided by 4, I get 3. If I take 36 divided by 12, I get 3. So everything is getting multiplied by 3 to find the next two terms. So this is my common ratio. So then I would use this equation above and try to solve that. So give that a try. I'm going to try to keep this video short. It's already at 16 minutes, but hopefully that helps you. If not, please email me and I can try to give you another video on something else. Thank you for reaching out. Bye.